So recall, we previously discussed mathematical induction. And so the way mathematical induction worked is we had something we were trying to prove. Usually it's some kind of formula to prove Pn, and we want to show it's true for every integer n greater than or equal to some fixed number, which I'm going to call a here. Remember that there's two parts. So the first part is the basis step, which is that your formula or your statement PA is true. So your statement or your formula is true for an initial value. And then part two is the inductive step, which says for every integer k greater than or equal to a, if pk is true, then pk plus 1 is true. So if some arbitrary value is true, then the next value would also be true. So what we're going to do is we're going to talk about something related to mathematical induction, and that's called strong induction. And it works very similar to regular induction. It's just a little bit more involved. So let me state how it works. You're still trying to prove some formula or some statement is true for every integer n greater than or equal to a. You must show. So there's still two parts, and they have the same names that they did before. The basis step. Now, one thing that changes is your basis step, it's not just an initial value that you need. It might be more than just one value. So PA plus 1, all the way up to some PB are all true, where A is less than or equal to B. So it might not just be one initial value, it might be two initial values or three initial values. It depends on your setup. And then part two is we still call it the inductive step. So I'm going to state it for every integer k that's at least as big as your b, which is this b comes from the last value in your basis step. If pi is true for each integer I from a through k, then pk plus 1 is true. So here, you're not just assuming the pk is true, you're assuming PA all the way up through PK is true. So you're getting more assumption in this inductive step than with regular induction. P is true for each integer I from A through K. So you're getting many more assumptions to use, which is why we call it strong induction, because it's so much stronger. So I will mention here that this is the inductive step is really where we see the biggest difference between these two. So the main difference between regular mathematical induction and strong mathematical induction comes down to the inductive step. The basis steps are very similar. You're showing that the formula is true for one value with induction or multiple values with strong induction, but the main difference again comes down to this inductive step. In regular induction, you get one assumption, but here you get many more assumptions.